What's going on, everyone? Welcome back to the channel. And in this video, we're going to talk about the significant severe weather outbreak on Saturday, including parts of the Ohio Valley, Mid-South, and Dixie Alley. As you can see here by the SBC Outlook, there is a moderate risk, level 4 out of 5, in parts of Dixie Alley, including the states of Louisiana, Mississippi, and Alabama. As we take a look at the probabilistic, we can see that over 24 million people are inside the risk, including cities such as Nashville, Tennessee, New Orleans, Louisiana, Atlanta, Georgia, Birmingham, Alabama, and Baton Rouge, Louisiana. With this information, let's go ahead and get into the models. Let's go ahead and start off with the 500 millibar chart. On this chart, we're going to be looking for troughs. Troughs are going to be areas of low pressure that's going to enhance storm development due to the advection of relative vorticity. As you can see at 7 a.m., we have two different areas. We have a cutoff low trough that is located in southeast Minnesota. But for this moderate risk and more of Dixie Alley, the main trough we want to look for is in southwest Great Plains that takes on much of a neutral tilt. And as you can see with the Rossby wave, this is going to be dominated by the advection of relative vorticity, simply meaning that the trough will continue to move off to the east-northeast direction. With that information, let's go ahead and put this into a loop and see how it develops. As we go into time, we could see that at 8 by 18Z or 1 p.m. Central Daylight Time, there is a good area of the mid-level jet that is definitely developing right around the Dixie Alley region and more of the southeast Great Plains and parts of the Mid-South. In addition, we do see defluence of winds. Defluence of winds are going to show as far as the divergence. So we have more of a winds going more towards the north-northeast, and then winds here coming more towards kind of like the east-northeast. And then inside of that area is going to be enhancing the area for vertical motion or storm development. With that information, let's continue to put this into a loop and see how it develops. Go a little bit more in time. We'll stop here at 0Z or 7 p.m. Central Daylight Time. We can see that we have a new jet max that is located through parts of Texas. That's going to continue to advect off into parts of the Dixie Alley. In addition, we see the defluence of winds that is increasing. We have more of a north-northeast direction, and then here more of an east-northeast direction. And inside that whole thing is going to enhance the risk for vertical motion. With that being said, let's go ahead and continue on and see how this continues to develop. So we can see that jet max is starting to transverse through parts of Mississippi. But also, too, it depends on different atmospheric dynamics if that's going to be a huge dynamic factor. But there definitely is a solid mid-level jet and defluence to work with up until we get to about 09Z, which, if I remember correctly, is 4 a.m. Central Daylight Time. And then you don't see as much as the defluence of the winds, which is going to show that this is going to be more of a QLCS factor after this, compared to a precursor of a more of the south direction, being a higher risk for the chance of supercellular development and about that region for a general area. And then if we just continue on just a little bit more, we can see then by 12Z and on, and then it's going to show as far as the following day that we do have along here that slight risk that is currently for our Sunday event. Next, let's go ahead and take a look at the vorticity. The vorticity is going to be the amount of spin in the atmosphere at the upper levels, which is going to enhance the chance for storm development. So as you can see at 7 a.m. Central Daylight Time, or if you're in Indiana and parts of Ohio, it's going to be 8 a.m. Eastern Daylight Time. You can see that we have a good area as far as our spin that should enhance storm development. So with that information, let's go ahead and put this to a loop, see how this develops over time. You can see that we go another 3 hours, so then we're at 10 a.m. Central Daylight Time in parts of Mississippi. We have little pockets that shows that there's definitely going to be areas as far as more storm development should be occurring right around that time. And then we keep on going on, and you can see that the vorticity is definitely going to increase. And by the time we get to 7 p.m. Central Daylight Time, all the way throughout the entire risk area, we have a lot of vorticity or a lot of spin to work with. With that information, let's continue on and see how this keeps on developing. And as you can see, with the trough ejecting, it's going to enhance as far as the spin. So there definitely is plenty of vorticity that's going to be able to work with for this event. Next, let's go ahead and take a look at the 250 millibar chart. On this chart, we are mainly looking for two things. we're looking for the defluence of winds, which is going to show divergence of loft, which is going to increase the risk for vertical motion and supercellular development, and in addition, jet streaks to help, another uplift mechanism. So as we can see here at 7 a.m., much of that jet streak is located over the southern plains and the parts of Dixie Alley. However, the defluence is not showing much. We have a lot of those same vectors going off towards more of the northeast direction. But let's go ahead and put this into a loop and kind of see how this develops throughout time. So as we go, we get up to 18Z, which is going to be 1 p.m. Central Daylight Time. We can see that we have areas of divergence with the defluence of winds here in Arkansas going more of a northeast direction, and then more towards the Gulf that's going in more of an easterly northeast direction. So we have plenty of divergence of loft given around that area, which is going to increase the likelihood of supercellular development within that given time. With that being said, let's go ahead and continue on and see how this develops. So we can see right around 0Z, so that's going to be 7 p.m. We see that this right along this area is going to be, as far as that upper level jet that's going to be starting to evecting into our main focus region. We definitely have the defluence of winds with that divergence of loft, so that is definitely looking good for supercellular development. Let's go ahead and continue on. And then by the time we get to about 06Z, which is about 1 a.m., that upper level divergence definitely diminishes, and it looks like the supercellular development is definitely going to start to wean off. And then, of course, as we get further throughout into the morning hours, it definitely looks like this would be definitely more of a QLCS event, given the parameters of the 500 millibar and 250 millibar chart. Next, let's go ahead and take a look at the 700 millibar chart. On this chart, we're going to be looking for short waves. Short waves can act as another uplift mechanism. So how you're going to look for them is it's going to be the dipping of these isobars. So for instance, we definitely have a short wave that is located throughout parts of the Mid-South and Tennessee. It's going to be right in that area. That is one short wave. We also do have one often more of the eastern part of Indiana. And then if we look further down, we have a kind of like more of a miniature one going through parts of Mississippi. And then we have another one right off the coast of Louisiana, and even more back throughout here. So as you can see, definitely a lot of short waves to work with that's going to enhance either a storm development or intensification of already ongoing storms. So with that information, let's go ahead and put that into a loop and see how this is going to develop over time. So as we keep going on, and we can see even there by 1 p.m., we have that new mid-level jet that's going to be evecting off into much parts of central to northern Mississippi. In addition, you can see that there is a little bit of that dipping down there that's going to have a short wave. So if there's any storms that is ahead of the line, you're going to have warm air advection that's going to be ahead of the short wave. And then you'll have cold air advection that's going to be behind it. Of course, we want warm air advection, and we want veering with the winds, or as far as the chances for supercellular development. So it looks about like right around that time, the chances for supercellular development could definitely increase. And then when we have another little short wave that is kind of throughout here too. And then if we look more up into parts of the Ohio Valley, it looks like they're kind of diminishing. Yes, we have a good like pressure gradient with these real close. That's going to show us like the good winds, but I don't see a whole lot of dipping per se. So maybe more of a subtle short wave. With that information, let's continue on and go throughout the rest of this run. So as you can see there at 21Z, more of that jet is developing in parts of Mississippi, Tennessee, and Alabama. And it's going to be evecting even more, as more on that northern side it's going to be being more of that QLCS compared to the southern region. Here at 10 p.m., we're going to have a short wave that is throughout here. That's going to be starting to show possibly storm development. That's going to be happening more here and more of central, southeast, southerly of Alabama. And then if we go ahead and continue to keep putting that into a loop for the rest of the run, see how it develops over time. Yeah, we can see as far as there's definitely a good amount of short waves and mid-level jet, so nothing as far as a limiting factor in this category. Next, let's take a look at the vertical velocity. The vertical velocity is going to increase the chances for uplift and also help you visualize right around where those short waves are. So as we were talking before, we have a short wave that is going to be located in more of southeast Indiana and even parts of the mid-south and in Dixie Alley. There's definitely a lot of vertical velocity to work with here at 7 a.m., which probably ongoing storms is going to be happening throughout more of the Dixie Alley region. And depending on how those storms develop too and the shear vectors, if they move at more of a kind of a north-northeast direction, if they have any outflow boundaries, the outflow boundaries will typically move away from it in more of an easterly direction. And if there's minimal cloud cover and the atmosphere can destabilize over time, that could also increase the chance for severe weather, given another trigger mechanism if the atmosphere can recover. So with that information being said, let's go ahead and put this into a loop, see how it develops over time. So as we can see, parts of the Arkansas, Louisiana, Mississippi border, a lot of vertical velocity is setting in. And then there we go by 18Z, like we are talking about before in the other charts, 1 p.m. We have a lot of vertical velocity to work with, which is definitely going to show as far as storms mainly going to be going on throughout the region and parts of more northern Mississippi to northwest Alabama and parts of Tennessee. In addition, we could have as far as a QLCS that's kind of developing throughout here too, and maybe more of an MCS that is more in the southeast Missouri, western Kentucky, and in those regions. So with that information, let's go ahead and continue on and put this in the rest of the loop so it develops over time. As we can see, it's in the parts of Dixie Alley, that vertical velocity is increasing. And by the time we get to 03Z, which is going to be 10 p.m., we can see this line of vertical velocity, which is a very good indicator of a QLCS occurring right there. Then if you have more of these kind of southerly parameters, that it's a little bit more isolated, which shows that there could be possible supercells ongoing in these regions, which around about 10 p.m. it looks like around the border of Mississippi and Alabama and kind of in this region which I circled, looks like might be the new focal point given the metrics. So let's go ahead and continue on, finish the run on this one. So as we can see, the vertical velocity is definitely there as we go into Alabama, and then we start to go into parts of into Georgia. And there definitely is a lot of vertical velocity to work with, and definitely going to be some strong storms of more of a QLCS given around once we get to this time at 15Z, otherwise known as, I believe that is 10 a.m. Eastern Daylight Time. Now we'll use the NAM nest to just compare the vertical velocity. And with the NAM nest, it's also known as the NAM 3 kilometer. It has higher resolution than the NAM than the 12 kilometer. So this will give us a better indicator of where this vertical velocity could be occurring. So here we are, 7 a.m. Central Daylight Time. And as we go throughout time, you can see these definitely little pockets are going to be affecting off more towards the north. And then we get to 18Z, and you can see we have our different regions with vertical velocity. That's going to be through much parts of in here, and more of around this region looks to be more of an isolated chance for our sails. Let's go ahead and continue on from there and just see how this run develops so we can do a quicker comparison so it don't take too long for this video. And then, yeah, we can see by 20Z, which is going to be, I believe, 3 p.m. Central Daylight Time, that it's going to start to enhance. And then over time, you can see that QLCS developing by the time we get to 03Z or 10 p.m. Central Daylight Time. And that system's going to keep on transversing off to the east-northeast, giving the storm vectors. And then right around that time, even 06Z and even before too, you can see here we are 05Z. So this is going to be what, midnight. So you can see a good chance for possible cells develop here. So this definitely could be also a nocturnal threat too. So you want to make sure you have some kind of warning system or something to wake you up, because you might need to wake up in the middle of the night if you're not still up by this time to be able to take cover if these parameters actually verify. So with that being said, let's go ahead and continue on for the rest of the run. Just do a quick little comparison. And then as you can see throughout there that the vertical velocity definitely starts to dwindle off a little bit more and shows more of a QLCS and a less chance for the supercellular development. Next, let's go ahead and jump to the 850 millibar chart, also known as a lower level jet. Taking a first look, we can see these winds directing out of the Gulf are going to help steer the moisture that's going to be evected off from the Dixie Alley into the Mid-South and into parts of the Ohio Valley which shows there definitely will be plenty of moisture to work with. And of course, we can verify that with dew points as we get further into this forecast discussion. So with that being said, let's go ahead and put this into a loop and see how this lower level jet develops over time. And there we go. So 18Z, 1 p.m. Central Daylight Time. We can see that we definitely have a nice little jet max that's going to be located through much parts of Mississippi, also into Alabama, and also in Louisiana. Let's go ahead and keep on going and see how this jet is going to develop over time. So we can see at 21Z, you see that little purple area. I'll circle it just in case you don't. That's going to be right along the border of Alabama and Mississippi. So we have a new jet max, but we have plenty of lower level jet to work with. And if we continue on for the loop through here, you can see by 7 p.m. that jet is definitely strengthening. And of course, we get after sunset. So that lower level jet's going to be strengthening because we're losing as far as our daytime heating. So the ground friction is going to be less, which is going to increase the 850 millibar jet to be able to go faster than normal compared during the daytime due to less friction. So with that being said, let's keep on going, see how this develops over time. And we can see at 06Z and more of kind of parts we were talking about before, kind of central Alabama to more south Alabama, given our other parameters. It looks to be a good overlap. So that might be the highest risk for tornadic probability given, what is this, 1 a.m. Central Daylight Time. And then if we go ahead and continue to keep putting this into a loop for the rest of the run till 12Z, we can see that definitely there is a lot of lower level jet to work with for this parameter. Next, let's go ahead and take a look at the dew point temperature at this pressure level. We can see that there is plenty of moisture to work with all the way out through our risk area, stretching from Dixie Alley into the Mid-South and up into the Ohio Valley. In addition, as you see these different wind vectors, the longer the wind vector it is, it's going to be the stronger of that lower level jet, which is kind of give you that visualization about the moisture transport I was talking about. So with that being said, let's go ahead and put this to a loop, see how this develops. You can see there we go at 1 p.m. Central Daylight Time. There is an abundance of moisture happening in Mississippi area, which I believe right around there is going to be the focal point around this time. And it's definitely going to increase. So then we go 4 p.m. Central Daylight Time. We keep on going to 7 p.m. And there's definitely going to be plenty of moisture to work with. And then even by, what is that, 03, so 10 p.m. Central Daylight Time or 11 p.m. Eastern Daylight Time. If you remember, there's even a little slight risk that's up here in eastern parts of Indiana and to kind of the Ohio and Kentucky area. So it looks like maybe a less chance as far as tornadic probabilities, but definitely could be a QLCS going on and probably a higher probability of those damaging winds. Definitely shows that there's not going to be a lot of dry air that's where it's going to help cut off those storms. So those storms should be able to maintain at that time. And as we go ahead and continue on throughout the loop, we can see, like we're talking about, this is going to be 1 a.m. Central Daylight Time. Most of the abundance of moisture is going to be located in the Alabama area, like we're talking about. And continuing on throughout the run, we can see that there's plenty of moisture to work with. And of course, into Sunday, slight risk, there's going to be plenty of moisture for those storms to work with. Next, let's go ahead and jump to our surface. So as we can see at 7 a.m., we have a surface low that's going to be located over the border of Iowa and Minnesota. Now, as far as finding our fronts, it looks like we're going to have an occlusion front. As we can tell with the temperature gradient, it's very minimal, a very minimal wind shift. An occlusion front is going to be a fancier term for a front that it's the cold front is catching up to the warm front, which is starting to create the occlusion process. Continuing on, as we draw in our cold front, we're going to have a cold front that's going to be draped right along that area. The main ways we can tell is we have warmer temperatures ahead of it, colder temperatures behind the front. In addition, we have a difference in wind shifts. We have winds coming more out of the south compared to more out of the southwest or westerly behind the front. Another one too, if we look at our dew point temperature too, it's definitely lines up pretty well with that. And then even our wet bulb temperature too, which shows that area. And we have these pressure tongues too, which is kind of similar to when we're looking for the short waves that are going to be more of those dip in the isobars. That shows us that that front is going to be set up in there. So let's go ahead and put this into a loop and see how it develops over time. So as we put this into a loop, we can see that there looks to be new surface low cyclogenesis happening in Dixie Alley. And as we get to 0Z or 7 p.m. Central Daylight Time, we have a new surface low that's going to be located over western Tennessee. We also do have that other surface low here. We're going to have an occlusion front that's going to be going up to about northern part of Michigan and to Canada, with a cold front that's going to be going right back to the surface low, and then a warm front that's going to be more draped along that region. And this occlusion just means that this cold front is catching up to this warm front, so it's starting to be the occlusion process. So anything ahead of this line is going to be, as far as the area, even in more the slight risk and parts of the moderate risk too, that's going to show as far as our main uplift mechanism. And then looking at more down the southern, at more of that moderate risk and parts of the enhanced risk, we can see that we have a surface low that's going to have a cold front that's going to be draped more along that area. A couple of ways we can tell. First of all, like we're talking about, so minute differences in temperature. We have 70s ahead of it, 60s behind it. We have more of a from the southeast winds ahead of it, and then behind the front, I have more of kind of our westerly winds. We have these nice little pressure tongues. We go to the dew point temperature. We can see that that matches up pretty well too. Looks like there might be also a secondary cold front that might be draped a little bit behind here too, but this is going to be our main one, and this is going to be the most dominant one in severe weather. And then we'll take one more look at the wet bulb temperature, which definitely shows as far as our different gradients on each side. So it looks to be our main precursor. And then of course, as we go further into time, we can see that that is going to shift off to the east. And then by the time we get to 12Z, we're going to have a new surface low that's going to be located over the Great Lakes. And we're going to have, it looks like, a warm front kind of throughout here. And then more of a, almost looks like two cold fronts. It's like a cold front that is draped down along here. And then even another one, and you could have two cold fronts from the same surface low too. That is definitely possible as long as it's not an occlusion front. And then it looks like there might be a secondary area too, but anywhere that's going to be behind this first one is going to have less chances for severe weather, and ahead of it's going to have higher probabilities for severe weather. And of course, that's going to transverse off to the east direction, and that's going to be our main uplift mechanism for Sunday's event. Next, let's go ahead and take a look at our mixed layer cape and mixed layer SIN, or convective inhibition. So here we're looking at our thunderstorm fuel. You can have all the other parameters, but if you don't have the fuel, you're not going to go anywhere, and vice versa. So as we can see at 7 a.m., our main fuel is going to be located in Dixie Alley and in the deep south. And then we do have a little area kind of in the Ohio Valley and also in parts of the Mid-South. So let's see how this develops as daytime heating occurs. This is definitely going to increase. And we can see at 18Z or 1 p.m., it looks like more of the northern area, which I believe is more kind of that slight risk. The southern region of this circle that I drew is also in the enhanced risk too as well. But it looks like that might be peaking for more of these northerly storms around that time, and after that it might be dwindling off into more of a QLCS. But as far as supercellular development, looks to be more keen there. Of course, down here in the Dixie Alley, we can see that that thunderstorm fuel is definitely building. With that information, let's go ahead and continue on, go through the loop. And yeah, there we go. So 7 p.m., we can see that it's definitely dwindling off here. There's still ample amount, but it's going to be more of a QLCS event, and it's not going to be as much supercellular. However, down here in the deep south is going to be our new focus area with plenty of thunderstorm fuel. So with that, we'll keep on going with the run, see how it develops over time. And then we can see about 06Z to 09Z, so that is 1 a.m. to 4 a.m. Central Daylight Time, that is definitely going to start to dwindle off. And then it looks like it's going to have a higher chance to go into more of a QLCS event. Next, let's go ahead and take a look at the most unstable cape and our shear vectors. As we can see at 7 a.m., we have majority of that most unstable cape that's going to be located in parts of the Mid-South and also in the Dixie Alley. Let's go ahead and put this into a loop and see how this develops over time. And we can see that a lot of that area is definitely increasing. So there we go. So that matches up with the mixed layer cape too, right? So at the 1 p.m., how we're talking about that area just on the mixed layer cape, that definitely shows an extra level of congruency of why supercellular development might be peaking around 1 p.m., given in the Ohio Valley and parts of the Mid-South. In addition, you can see that it's definitely building throughout Dixie Alley. And then if we keep on going throughout the loop, we can see it starts to dwindle off, but let's go ahead and stop here at 21Z and let's take a look at our shear vectors. So the way we're going to do this, we're going to go back to our surface. We'll go to 21Z. We're going to draw on our fronts real quick here. So we have that one surface low there, and then it looks like we have this extra surface low. That's about like right on there. Let's just focus on more of this southerly one. So we have more of that front, and then if we go back and take a look, let's go back to convective, and the cape. So now we're looking at the shear vectors, and we want more of a, as they say, orthogonal, or more of a right angle. So more in the more northerly direction, these ones are more parallel to shows a higher chance for QLCS. However, in more of northern Mississippi and to southern Mississippi and parts of Alabama and this whole area here, you can see that the winds are going to be, for the shear vectors, more off to the east-northeast, which is going to be a little bit more of not necessarily a right angle, but a little bit more perpendicular, which is going to increase the chance for supercellular development. With that being said, let's go ahead and continue in time, see how this develops, and also a most unstable cape. It's also a good indicator to see how much of a nocturnal threat this could be. So as we continue on at 7 p.m., we can see it's definitely maintaining, especially in Mississippi, Louisiana, and in Alabama. It's going to keep on transversing, 10 p.m. It definitely holds up very well, even all the way up until 1 a.m. Central Daylight Time. And then it's going to start evecting off at 12, which is going to be at 7 a.m. So about 7 a.m., it looks like it's going to start to dwindle off and go into more of that QLCS. But it definitely looks to have enough energy to work with that it's going to be from about like 4 p.m. all the way to, what I say, about 4 a.m. for good chances of supercellular development happening throughout much of that moderate risk area in that region. Next, let's go ahead and take a look at the mid-level lapse rates. Here we're looking for values above 7 degrees Celsius per kilometer. These are going to show good indicators for increasing the chances for supercellular development and also large hail. So as you can see here at 7 a.m., predominantly resides in parts of the Mid-South and also in Dixie Alley. As we go into a loop, we can definitely see Louisiana and into parts of Mississippi here at 1 p.m. And then it gets dominant in Mississippi at 4 p.m. And then it starts to, you got little pockets there in Alabama, and then it definitely starts to dwindle off those lapse rates, which definitely shows that it's going to form into more of a QLCS line somewhere between 1 a.m. to 4 a.m. Next, let's go ahead and take a look at our supercell composite with the 500 millibar and 800 millibar wind crossover. So here we are, 7 a.m. As we can see, as we go into a loop, get to 1 p.m. as far as the supercell potential is definitely increasing in much parts of Mississippi. We get to 21Z, which is going to be 4 p.m. It has gotten even brighter. And so with this, we can see these nice little pink regions. So let's go ahead and give this a click in central North Mississippi for our first sounding. So initially, taking a look at the hodograph, we see there is an abundance of speed and directional shear. We can see this with a more of a backed surface wind, which just means it's from more of the south or southeasterly direction, which is what you want for tornado genesis. And over time, you can see those winds are definitely varying with height, with the only exception around the 700 millibar region with a slight backed wind with some cold air advection, which could be on the, once a shortwave has gone through, on the backside is going to have cold air advection on that shortwave. However, if you remember, there's definitely an abundance of shortwaves, and on the leading edge of a next shortwave, there could be warm air advection that could help intensify this, but this is not going to be a huge limiting factor. With this, we can see that our mixed layer cape is over 2,500 joules per kilogram, which is definitely a lot to work with. Our lithium index is -10, so very unstable atmosphere. For a 3 cape at 115 joules per kilogram, which to visualize is going to be from the LCL all the way up into the 700 millibars. So in that region, give you a little visualization. We have our storm relative helicity effective at 605 meters squared per second squared, which is an astronomical amount of spin. We have that deep layer shear too that's going to help as far as hailstone growth, and encompass with that 700 to 500 millibar lapse rate of 8.5 degrees Celsius per kilometer, which definitely shows the significant hail index parameter of possibly 3.4 inches in diameter for very large hail, or like Reed-Timmer always talks about, gorilla hail. And then going a little bit further on, we can see our DK values is 917 joules per kilogram, which is definitely a good moderate amount. So at this time in this area, it looks like to be a high chance for tornadic development, also damaging winds and large hail, but predominantly large hail and damaging winds. And then we could see that we have our lower level jet and our mid-level jet. So that lower level jet is 65 knots, which is astronomical, and that mid-level jet is 80 knots. Throughout research, typically for long track violent tornadoes, anything for that mid-level jet around 75 knots as a rule of thumb definitely gives us an extra convergence of evidence that this atmosphere is going to be extremely volatile and nothing to mess around with. So make sure you're staying weather aware and have multiple ways to receive warnings. Now we're going to go ahead and take a look at our simulated infrared satellite. Here we're looking at the cloud tops, which the colder it is, the higher risk for our updrafts. So as we can see here at 7 a.m., we definitely are going to have some kind of storms occurring throughout much parts of Dixie Alley. Let's go ahead and put this into a loop and kind of see how this transverses through time. You can see over time that they're definitely going to be building and moving a little bit more northerly, and going to be organizing into more of a MCS. And then we got these individual storms. So here we are, 1 p.m. So we have some more individual ones, little clusters of storms throughout here and here. That definitely shows that they possibly could be supercellular in development. As we go ahead and continue on throughout the loop, we can see that there is definitely a good area of more storms firing along that border of Arkansas, Mississippi, and Louisiana. And then continuing on 21Z, so that's 4 p.m. A little bit south of the line, we're going to have some more storms firing. And then even as we go throughout time, right around, see 05Z, which is going to be midnight Central Daylight Time, we have this area in Alabama, and more of the southerly, that definitely shows that there could be some supercellular discrete firing and definitely could show a nocturnal threat for tornadoes. And then finally, as we go ahead and continue on, we can see that those develop a little bit more before finally getting absorbed into a more of a line by 5 a.m. Eastern Daylight Time. Next, let's go ahead and take a look at our precipitable water values. So typically here, we want to look for values that are going to be 1 inch or greater. So we're looking for these dark greens into these blue regions. So as you can see at 7 a.m. throughout much of that risk area from Ohio Valley to Mid-South to Dixie Alley, there's definitely plenty of precipitable water to work with initially. As we go throughout time, you can see that there's more precipitable water that kind of gets cut off in parts of western Kentucky, Tennessee, and also into Indiana. However, as we transverse into time, you can see that that moisture is going to be infecting back into those regions, which definitely shows that there's enough sufficient precipitable water to work with for these storms to develop. Lastly, let's go ahead and take a look at the simulated reflectivity, or what the radar could look like. So here we are, 7 a.m. We can see that there's a good line of storms throughout the Ohio Valley, Mid-South, and starting to be in parts of Dixie Alley. As we go ahead and go into time, we can see more of those storms conforming together, becoming more of an MCS as they transverse more towards the north-northeast direction. And then by the time we get to about 03Z, which is going to be 10 p.m. Central Daylight Time or 11 p.m. Eastern Daylight Time, depending if you're in Indiana and Ohio or western part of Kentucky or where you might be, that it's going to start to form a QLCS, and damaging winds are definitely going to be a risk for here. We also see in parts of Alabama and also in Mississippi that there's going to be some discrete cells that are going to be ahead of this. And then as we go ahead and transverse in time, it looks like by 9Z, or otherwise known as 5 a.m. Eastern Daylight Time or 4 a.m. Central Daylight Time, that it's going to form into a QLCS and transverse through time. And then, of course, that line will go through for Sunday's event on the eastern seaboard. So that's going to go ahead and wrap up this video. So it looks like the main threat is going to be between the hours of 1 p.m. and 1 a.m. Central Daylight Time, with the peak between 4 p.m. and 1 a.m. Central Daylight Time. So this is definitely not a day to mess around. There could be long track, devastating tornadoes damaging straight line winds, and also large hail. So make sure you have your safety plan in place and are ready to act before weather strikes. Make sure you have some way to receive warnings, as this is definitely, once again, not a day to mess around. I hope you enjoyed this video, and until next time.